Okay, this is the second example of determining the equilibrium concentrations when you're given Kc and the initial concentration. So the steps are, I'm going to write down the balanced reaction. I'm going to do I, and I'm going to make a list over here of what I have. I have Kc is equal to 49. I have the temperature is equal to 230 degrees C. And I have a volume of 4.0 liters. I'm told I have 0.4 moles of each phosphorus trichloride, so 0.400 moles and 0.400 moles. And wants to know what is the equilibrium composition at 230 degrees. So my initial PCl5 is 0. Again, in order to use the equilibrium constant expression, I have to be in molarity. So I'm going to start out by dividing all of these by 4.0, which is my volume. So liters. So I'm going to add a column, and I call that I in molarity. This is going to be 0.10 molar, 00 molar, 0.100 molar, and 0 molar. The C's as a reactant is going to decrease. Again, as a reactant, and as a product it's going to increase. And what I'm looking for is my E. So my equilibrium constant expression is Kc, it's concentration of PCl5 over PCl3 and Cl2. It's feeling very ambitious today there. So 49 is X. It's 0 plus X, but I drop the 0. Over PCl3 is 0.100 minus X. And chlorine is 0.100 minus X. Okay, so the first thing I'm going to do is combine these two terms using the FOIL. So it's going to be 49 is equal to X over, the first is 0.1 times 0.1, so it's going to be 0.01. Outer is 0.1 times minus X, so it's going to be minus 0.1 X. Inner is minus X and 0.1, so minus 0.1 X. And last is minus X times minus X, so it becomes a positive X squared. I'm going to combine these two terms because they're like terms, so it's going to be negative 0.20x. Okay. And this really has 3 zeros after it. Okay. Then I'm going to multiply through by the denominator. I'm going to move over here. So it's going to be 49 times 0.010 0 minus 0.200x plus x squared is equal to x. Now I do a distribution of 49, so I get 0.49 minus 9.8x plus 49x squared. And I'm trying to get to ax squared plus or minus bx plus or minus c. And this is equal to x. So I'm going to do two things at one time. I'm going to put it into that order, and I'm going to move the x over because I want my a to be positive. So I have 49x squared minus 9.8x. I'm going to go ahead and put this one here, minus 1x plus 0.49 is equal to x. I combine these like terms. Don't know how to undo that. How do I undo? There we go. So I get 49x squared minus 10x, 10.8. Plus 0.49 is equal to 0. So here's my A, my B, and my C. And I'm going to put this into, I'm going to change colors here. I'm going to put this into the quadratic equation, which is x is equal to a minus b. So x is equal to a plus 10.8 plus or minus the square root of b squared, so negative 10.8 squared. And I usually drop that negative because when I square even a negative, it becomes that positive, but I'll put it there just so you understand it. Minus 4 times a, which is 49, times c, which is 0.49, all divided by 2 times 49. So when I do the positive term, x is equal to 0.156. When I do the negative term, and what I'm talking about positive versus negative is this is the positive, that's the negative, I get a 0.0639. Now, I have two answers here. Unlike the last problem in which it was obvious because one of my x's turned out to be negative, which can't be true, this one does not work that way. So I need to look at this. So if this is 0.1 minus x, I'm trying to figure out where to go here. So I have 0.1 minus 0.156. I would end up with a negative number. That's right, negative. I can't have a negative concentration, so this one is not true, which means I do not use this one. So I'm instead going to have 0.100 minus 0.06639, and that's going to be true for both of these. So what I end up with is a 0.036, a 0.036, and a 0.639. And actually, for Alex, you need to have one more significant digits, and so this ends up being 0.0361 here. And the units for this are molarity. And so this is my final answer here. There you go.